What you want to do on this problem is find your slope, and then once you found the slope, use the y-intercept and plug them straight into slope-intercept form. Done. So, slope. What are my two coordinates? The x-intercept, what coordinate is that? 6, 0. 0, 6 would be a y-intercept. So this is 6, 0. And what is my y-intercept coordinate? 0, 3. When in doubt, quickly graph them. Y-intercept is here, that's 0, 3. X-intercept is here-ish, and that's 6, 0. Alright, so finding the slope. y2 minus y1 over x2 minus x1. 3 over negative 6 is negative 1/2. And then that's our slope. There's our y-intercept. So our equation is just y equals, hold on. Y equals negative 1/2 x, our slope, plus 3. Just plug the points into the slope formula. That's a 0. That's a 0. It's a 0. It's a black hole of nothingness.
How's 0 minus 6 too?
Yes. 3 minus 0 and 0 minus 6. Hence, negative 1/2.
Never mind, because it was so you're
Okay. Questions on that? Are there questions? No? Okay. In that case, we're going to go on. Today's, well, actually, before we get to today, quick little review over what we've done in the last few days. Here are the 3 equations for lines that I have told you so far. Slope-intercept, point-slope, standard. Slope-intercept is the one that's going to be the most useful when you graph. However, most of the time, when you have to make your equation, you're going to use point-slope because that's the one that's easiest to make with most information unless they give you the y-intercept, which only happens like 2% of the time. In standard's really not used for anything, but the book loves to give you equations in standard form because they look prettiest, but most of the time you just have to take standard and solve for one of the others. Now, like I said, there are ways to use standard form to quickly find your slope and your y-intercept, but it's no harder than just solving for y and pulling them out just like that. Okay.
Why did they come up with standard form if it's not even useful?
Well, it is useful for people who I don't like fractions, I don't like decimals. Well, standard's perfect because it doesn't have any of those. And the first number is not even negative all the time. So, I mean, it's like never negative. So, most people like standard form because it's pretty. Everything's a nice whole number, and you can go frolicking in the easy clouds of easiness. But in real life, yes, it has no purpose. Okay. It's really there for the people who like things just right. All the perfectionists in the world, the people who if I were to walk on their desk and turn their calculator sideways, that would freak out. Those people like standard form because it's pretty. But anyway, none of that has anything to do with what we're doing today. What we're doing today is talking about if lines are parallel and perpendicular. And the first thing that we're going to talk about is if they are parallel. Who thinks they know what parallel lines are going to have in common? Joseph. Yeah, well, just explain to me what parallel lines are.
They're like an equal sign.
Yeah, they're going to... Keith.
Oh, they would never intersect.
That's right. They're going to run right along next to each other and never touch. Now, the way that's going to affect you today is that, and here's the key thing of the day, I'm going to tell you 2 key things. Here's one of them, and here's what you need to notice. Parallel lines have the exact same slope. If 2 lines are parallel, then they have the same slope. I'll even say it one more time to make sure it sinks in, because this is seriously half of what you need to learn today. Parallel lines have the same slope. Cameron, parallel lines have what kind of slopes? Ryan, parallel lines have what kind of slopes?
The same.
That's right. Gerard, if 2 lines are parallel, then their slopes are what with each other?
They're the same.
They are. Good. Excellent. Now, look what it's telling us here. we're supposed to find an equation that goes through this point, but we don't know the slope of this equation. All we know, bless you, is that it's parallel to this equation. But this equation has a slope of what? -3. So if our line is bing, 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 parallel to it, then our line is going to have a slope of -3. Because they're the same, they're the same, they're the same. And if this one has -3, then ours will have a slope of -3. And that's really all you need to take out of that problem. So our slope is -3 because it's the same as this one because they are parallel. Keywords, keywords, keywords. Okay, now let's actually work this problem. So we have a point, we have our slope. Point and a slope. How should we find our equation for a line? Point. Thank you, Cameron. You're the man today. Point slope form. Point slope form. Y minus y1 equals m times x minus x1. So our slope is -3, and our point is -1, -2. So y minus -2 equal. It would. And then -3 times x minus -1, which again would be +1. But it actually wants our answer in slope-intercept form. So what do we have to do? Rhymes with molve for y. Solve for y, that's right. So y plus 2 equals -3x minus 3 when you distribute. You're correct. Now what do I needs to do's? Minus 2. Done. Y equals -3x minus 5. Where a lot of people are going to mess up on these is they're going to overthink this. They're going to be like, whoa, 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 whoa. Where do I use the -2, bro? And I'm going to be like, bro, you don't need the -2. All you needed from this line was the slope. Because we were parallel to that. We don't give a darn about the y-intercept. All we care about is if we're comparing our line to another line, is the slope. Questions?
Why would you use point slope?
Because we were given a point and the slope. You're right. But do you know the y-intercept? I mean, did you know it was -5 originally? So what you want to do, yeah, that's a good question, is start with point slope and then just solve for y-intercept. There are ways to use y-intercept right off the bat, but in my opinion, they're more complicated because what you have to do is you have to plug stuff in for variables and then unplug it in for variables, etc. Okay. Questions? Nope. All right. So that's parallel. The other key word of the day is perpendicular. Perpendicular. Now, if lines are perpendicular, their slopes will not be the same. They will be like as opposite as they can possibly be. So like if our slope is 3/7, the perpendicular slope to that would be -7/3. You flip it and you change its sign. Those two slopes would be perpendicular. Perpendicular by definition means if we were to graph these, they would form a perfect right angle when they crossed on the coordinate plane. However that angle would be, they would cross perfectly, just like that. Another way you know, bless you, another way you know if you found, I know, I'm a blesser. Another way you know that if you have found the perfect perpendicular slope is if you multiplied them, you should always get -1. I know, but you caught it. If you multiply them, you should get -1 when they're perpendicular. This would be -21/21, which would reduce to -1. So they are perpendicular. What would be perpendicular to -4/5? Anyone?
4/5.
+5/4. Just flip that thing over, change its sign. Very good. Fractions are... People are like, fractions, I hate you. But fractions are awesome because you can just flip them. If I give you a slope of like 2.5, well, that's not as easy. You'd have to like do all kinds of crazy stuff. So fractions are our friends. Now, what if it doesn't give it to you as a fraction? What if it's like, your slope is -3?
Over 1. Over 1.
Nice. If you were going to find its perpendicular, you'd put it over 1, then flip that bad boy, and what would it be?
Positive 1.
+1/3. Just flip it and change it. That's it. I'm done saying it. Questions about how we're going to find perpendicular slopes? Good.
How would you
More or less. So,
How would you
Ru-
spell, like,
wh-
if it's
we-
-3 times 1 and just 1 times 10, how would that be?
how would that be -1 when you multiplied it?
Yeah. I mean, -3 times 1 is -3, but
Yeah, it'd be -3 over +3.
it just turns as a negative.
Well, it'll be, well, if you have a negative, it'll stick around, yeah. -3 over +3 will be, notice only one of them is negative, so they won't cancel, because they always change signs. What? Say that again? It would, and that's what you're supposed to get when you multiply perpendicular slopes. Okay, find the slope-intercept form of an equation with a point. We're just going to put recording. So they gave us a point, which we're just going to put in our pocket, and they tell us that we're perpendicular to this guy. Now, this guy, what's the slope of that guy? I have no idea. We ain't got no ideas.
Wait, the slope?
Yes. So what do we have to do to find the slope of that thing? Get y by itself. That's right. Now again, there are ways to find it in standard form, but then you have to remember like all these b over a and c over a equations. So I just think it's easier to solve for y. So we subtract the x, and you get 4y equals -x plus 12. Divide by 4. That's a -x. So y equals -x over 4 plus 3 when you divide everything by 4. Now, what's our slope now of this thing?
1 over
-1 over 4. So what's our perpendicular slope to that?
4 over 1.
That's right. Positive 4 over 1. And that's all you need from that line. Whenever we have a parallel and perpendicular problem, once you find the slope, you are done with that other line. You will not use any other part of it. The 3 doesn't come into play, the 12 doesn't come into play, nothing.
Or you said just 4 over 1.
Well, we're not done. Our slope is 4 over 1. That's what we were looking to find. What we actually are going to need here in the end, Amelia, is an equation in slope-intercept form. So, our slope is 4 over 1, which I'm just going to write as 4. And our point is -3, -2, so we're going to use what form? Well, that's what we need to get into, but we're given a point and a slope, so we're going to use that. Point slope, in my opinion, is like the money formula. That's the one you're going to use 90% of the time. Y minus -2, which is plus 2, equals our slope, times x minus -3. Solve for y. Oh, can't do that yet. Y plus 2 equals 4x plus 12. Subtract that there too, and you get Diaz. And that's it. That's your finished product. That is your equation in slope-intercept form, which is what we were going for. Questions about the process here? You're going to have an equation that you need to pull that slope out of, and then plug it in with your point and form an equation of your own. Try these. Try these two for yourself. I'll come around and assist. And then we'll... actually, I'll tell you what. Let's actually, right now, just work on number 10. Let's just do number 10, but I want you to find a perpendicular and parallel. The directions just say perpendicular. I want you to find the parallel and perpendicular equations for that line. Instead of doing 3 perpendiculars, we'll just do number 10, parallel and perpendicular. Number 10, first thing we're going to do is parallel. First thing we're going to do is parallel. What is parallel to the slope on number 10? Would be what slope?
3/5.
3/5. Whatever the slope is, then that's going to be the exact same slope in our line. Now, from here, I saw a lot of people using 3/5 correctly for the parallel part, but from here, I saw people putting -4 and -2. Point slope form. Point slope is what you want to use. So, point slope. Y minus my y value, which would be +2. Slope times x minus my x value. Okay, raise your hand if you need me to put point slope form on the board. If you need that equation. Okay. That's something you have to have at least in your notes, if not in your mind. Every single problem you're going to do today is going to come down to this. You're going to need to find your slope and then use point slope. Frighteningly few papers that I saw were in point slope form. So many people tried to jump from here and then put like, oh, -4. It's like, no, you don't need that -4 at all. We talked about that. When you're using a line and just being perpendicular parallel to that line, all you need is the slope. The -4 is never going to come into play. Y value, x value. And here we go. Now, I saw Gerard do something and I thought was kind of brilliant. If you don't want to deal with your fractions right now, you can get rid of them by multiplying by 5 if you wish. I think that's a cool way to do it. You don't have to do it like that. I'll work it without getting rid of the fraction, but you could do that if you wanted to. So that's y plus 2 equals 3/5 x. 3/5 times 6. 3 times -6 is -18. And then over 5. Now we need to subtract 2. So it's y. We're going to subtract 2. What is 2 in terms of fifths? Yeah, like if you had a pizza that was sliced into 5 slices, and you had 2 pizzas, how many slices is that? 10. Yeah. So when you subtract 2 from the right, it'll be just the same as subtracting 10/5. We have to have common denominator. So y equals 3/5 x. -18 minus 10 is -28/5. We had to convert -2 into fifths so that we could subtract. And basically, whenever you have to convert a whole number into a fraction, then just take whatever your denominator is and multiply that by the number you have to convert it into. So if you told me to convert, I don't know, if you told me to convert the number 5 into sevenths, well, that would just be 35 over 7, because you just multiply it. If you told me to convert -9 into fifths, that'd be -45 over 5. You just multiply. That's all you really have to do when you convert a whole number into a fraction. Just keep the denominator and multiply it by whatever number you're turning it into. So, you should have gotten 3/5 x minus 28/5, which would be 5 3/5. Yes? Yeah, that's perfect. I would prefer it like that, actually. Now, if you do not like converting fractions, if that's where you got thrown off in this whole thing, then you want to do the Gerard method. So I'm going to back up to my point slope form and work it using the Gerard method. If you don't mind if I call it that, do you? Yeah, I thought you would. So he ingeniously said, I don't want to deal with these stinking fractions. I'm going to multiply everything by 5, which turned this into 5y plus 10. Now remember what we talked about yesterday. When you multiply 5 times a product, you really just need to multiply it by one piece. 5 times 3/5, the 5's canceled, and it was 3 x minus 6, which gave him 5y plus, I'm running out of space. 5y plus 10 equals 3x minus 18. Subtract 10. Oh, 5y. I wonder if I can well, okay. You see, what I'm writing on right now, it's not the actual page. It's a picture of the page. Yeah. Did I talk about this recently? Yeah.
Yesterday.
Yeah, I thought so. So I actually can't extend the page. But anyway, 5y equals 3x minus 28. And then you divide everything by 5, which would give you y equals, I'm sorry I'm out of space, 3/5 x. What is that, minus 28/5? Which is the exact same thing we had a second ago. But at least you wouldn't have to, sorry, it kind of got crammed. At least you wouldn't have to convert numbers into fractions. You could just divide by 5 in the end. And I actually like that method. I prefer that method, but I don't want people to get confused. Be like, why are you doing that? Well, you could do that if you don't like dealing with the fraction. So either way, you get 3/5 x minus 5 3/5 or 28/5. Parallel. Now, brace yourself. The only thing that's going to change when I do perpendicular, this entire red line is not going to change. And I'm going to work it the exact same way. The only thing that's going to change is what? Rhymes with the pope.
Slope.
The slope. When I go from parallel to perpendicular, the only thing on this line that's going to change is my slope, which is going to be what? -5/3. You change the sign, flip your slope. So, does everybody have that who wants it before I erase it? I think I'm just going to undo. Because I'm determined to make it sink in that the red line will not change one little bit. The only thing that's going to change is the slope, which instead of 3/5 is going to become -5/3. And now we work it the exact same way. You still don't use the -4. All you need is the point in your new slope. Now, if we were going to do the Girard method, what would I need to multiply by this time? 3. That's correct. That way our fraction will vominos. So that's 3y plus 6 equals -5. Oh, hold on. That's not true. I just multiplied by 3. Equals -5 times x minus 6. So that's 3y plus 6 equals -5x plus 30. Subtract 6. 3y equals -5x plus 24. Divide everything by 3. And you get, boy, he is animated, -5/3 x. Dadgummit, I'm out of room again. And what would that be, plus 24/3? 24 divided by 3 when I divided that by 3? What is 24 divided by 3?
8.
Yeah, so it'd be plus 8. And I just ran out of space. -5/3 x plus 8.
Do you ever have to tell him, like, quiet down?
No. I love his passion.
He's yelling.
This is being recorded on YouTube, blah, 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 blah. Okay.
I want to hear him yelling.
Anyway, questions before we do another one. I cannot emphasize this enough. All you need is the slope from the original line, and then you have to use your point in point slope form. Okay, try number 11. We're going to do number 11 in both parallel and perpendicular. Now, number 11 is unlike number 10. Did you need something?
No.
Number 11 is unlike number 10 because it's not already in slope-intercept form. You're going to have to solve for y first. So you're doing number 11 in both point slope and slope-intercept. Number 11. The first step to any linear equation when you're trying to find its slope is you have to make sure y is solved for. Hush. So you need to subtract 2x. So that'll give you y equals 5 minus 2x, or -2x plus 5, however you wanted to write it. The slope is the number with the x, regardless of what order they're in. It's the number with the x. So our slope is -2. Now, I always like to do my parallel ones first, because that way I can just take the number as it is. So my slope is -2, and here's my point. So y minus -2 equals your slope times x minus 2. And again, that point's coming from right here. And now you just solve for y. Y plus 2 equals -2x plus 4. Subtract 2. And that's y equals negative 2x plus 2. That should have been the first one. Yes, sir.
Why is there a goldfish?
What?
Why is your eggs look like a goldfish?
Because this pen, it's like a squishy end, and when I pick up a little bit, it somehow still touches it a little bit, and it doesn't actually come off the board.
It's not dangerous.
Moving on. Questions about the parallel portion of that problem?
He would find something.
Yes, you would. Fantastic. Now, if negative 2 is our parallel slope, what is our perpendicular slope? If negative 2 is the parallel slope, what is the perpendicular slope? That's a question that if you do not know how to answer by the time you walk out of here today, you have work to do at home. Positive.
What now?
Because our original was negative, so this one's positive. So our perpendicular slope is going to be positive 1 over 2. It's the flip and inverse of this one.
Someone dropped their keyboard.
And then from there, it's the same problem. Y plus 2 equals 1/2 times x minus 2. Notice, nothing changed except for the slope. So that's y plus 2 equals 1/2 x. 1/2 times 1 is, 1x is negative 1. Add 2 to both sides. And that becomes y equals 1/2 x. What's negative 1 plus 2? What's 2 minus 1? 1, okay. Oh, I'm sorry, I didn't hear you. So y equals negative 1. So there at the bottom are my two answers. The blue one is parallel.
Wouldn't it be subtract 2? Yeah.
Oh, touche. It would be subtract 2. Minus 2, minus 2,
You told me to do it right.
which would make this minus 3. Good catch. All right. Here are your problems. Now, Lissy, what did you ask me earlier about homework?
Oh, when you go through all, do you go through all the homework? Like when you have
I look at it all and I grade 2 or 3 problems per assignment.
That's it?
Yep.
So we're doing. So pretty much getting a participation rate.
For your homework, more or less. I mean, I do look at a few of them for accuracy.
Whatever.
And if you miss like every problem, I'm going to take off points. But as long as you get a good portion of them, I just give it to you for doing it. Now, we do have one last kind of problem I forgot about. All you have to do is tell whether these are parallel, perpendicular, or neither. Now, what is the only thing about lines that you have to care about when it comes to finding out if they're parallel, perpendicular, or neither? The slope. All you care about is the slope. And to find the slope, we have to solve for what? Solve for y. You have to solve these for y. That way the two slopes will be staring you right in the face. And you can be like, oh, those are parallel, or perpendicular, or neither. So, and yes, you are going to have 2 in your homework like this. So we have to solve these for y. The top one, what's the only thing we have to do to the top one to solve it for y? Divide by 3. And that would be 2/3 x plus 14/3. Do I even care one little bitty bit about 14/3?
Nope.
No. No, I don't. All I care about is the 2/3. Now, quick little trivia question. If these two things are going to be parallel, what's the slope of my second one going to be?
2/3.
If they're perpendicular, what should the slope be? Okay, now let's look. So, solving this one for y, I'm thinking we'll subtract the 2x. So that's negative 3y equals 2 minus 2x. I just subtracted the 2x to the other side. So, what do I need to do now? Divide by negative 3? So y equals negative 2 over 3, which I don't really care about. Negative 2 divided by negative 3 is what? Positive 2/3? So are my lines parallel, perpendicular, or neither? They are parallel because this one is 2/3 and this one is 2/3. They are parallel. What?
Did you divide by 3? Or
Negative 3. Negative 3.
Wouldn't that make it positive 2/3?
It did. Oh, I see what you're looking at. No, it made the y-intercept negative 2/3, but I don't really care about that. It made the slope Positive 2/3.
Wouldn't it be minus 2/3? Oh, never mind.
Yeah, I mean the order's different because I didn't feel like changing it.
Then what I do wrong here?
Well, I don't know. I'll look at that in a second. Yes.
Can't you just look at the original problem?
That's
No.
what I did.
Because they both had 2's on them?
Yep.
No, that's a fluke. If this one had a 5 on the y, these would have been different.
But
So
aren't
no,
they
you
different
have to
because
solve them
this
for y.
one's negative?
What's that?
Aren't they different because one's negative and one's positive?
You mean the y's? Again, you can't even make. Wait, you mean on our finished product? No, they are the same. That's positive 2/3, and this one's positive 2/3.
Oh, that's what I was looking
Yeah,
at.
this is the y-intercept. Now, yeah,
I'm
this.
just confused because you're putting your intercept.
Well, I only did that because here's the only reason I did that is because when I subtracted the 2x over, I had positive 2 and negative 2x. Now you could have written that as negative 2x plus 2. If you just like writing the x first, then by all means do that. And that would be negative 2x plus 2. But I always like to put my positive number first because I'm a slave to standard form. I like things pretty.
So you have to. So wouldn't it be better if I
I've done that for you.
Yeah, it's always the number in front of the x is your slope. All right. Your assignment, and we're going to be doing some of these on the board tomorrow when you come in. Your assignment, assuming this thing will ever listen to me, is that.